this tutorial on exporting. So I've got some notes over here to remind me what to talk about. Yeah, so acoustics is generally difficult. The pod tries to take the acoustics out of acoustics, but you still end up with a lot of data, a tiny fraction of what you get from conventional wave files. And what we're trying to do, obviously, is answer non-acoustic questions like, did dolphins come here last night, using acoustic methods. And a lot of this material on exporting actually derives from the Samba project in the Baltic, where we had 400 years of data collected over 2 years in 1,400 files. And obviously, there's a lot of exporting involved in getting data you can actually use out of that lot. So the first thing I thought to show you was on this page of the menu. So the menu you get either by clicking on this green label here, or the menu button, or going up and down with the mouse pointer. So filters and files, list file time. So this is like the most basic tool. So when you click that, you can select files. So where should we go? Somewhere where I've got a lot of files. Okay. Britain, cat. So this is cetacean acoustic trend tracking. It's a project we're developing in Cornwall. So I only want to list either the FP1 or the FP3 files to avoid duplication. So in the drop down bottom right of the selection box, I'll pick FP3, and I've got these files. So all the files are in one folder. Generally speaking, that would be a folder called useful files. And okay, it's read them all, or at least their headers, and I'll cut that to the clipboard and drop it into Excel. Just expand that a bit. This is what you get, a list of the file names. I'm going to delete the file names, the path, and the pod, just so it's easier to see the whole lot. And then look at these. So we've got the start and the end in conventional dates. We've also got start minute and end minute. They're actually used a lot in the pod software. And in theory, they're supposed to be the number of minutes since the start of 1900. But Leah Crow, a PhD student in New Zealand, has pointed out to me that actually Microsoft and Windows have an error in this, and it's 2 days out. So if you put those numbers into R, the stats package, you will get a different result. So it might be best to get R to use the text version of the dates. What I commonly do when I've got this is just do a quick graph, because you get a very quick picture of how your files stack up, as it were. So because they're sorted by name, I'm getting one location initially, and the first file went from there to there, and the next from there to there, and you can see it's like working very neatly. It's basically running through continuously, etc. So it's just a quick way of getting a view of your files. You've got the number of days that they contain, and generally files with less than 2 days are essentially useless. You might want to hang on to them. Okay, so that's listing the files, and we'll kind of see more of that in a minute. So just a couple of points here. You really do want to keep all your files in one folder. The reason that we discovered in Samba is it's extraordinarily easy to get duplicates of files because people change files, particularly when you've got files coming in from different sources. So there we had like 9 different countries, different languages, different seafarers reading SD cards, etc., and people renaming files. If you've got them all in one folder, you can find these duplicates and errors from the file size and so on. Another thing is you should never type a file name. You probably won't find yourself doing that, but always copy it from somewhere. That avoids errors. Another important export for projects is the actual settings of the pods. So you can pick here operational settings. We're on the filters and files page. Either open FPOD files or other FPOD files. So I'll pick other FPOD files and back to the cat project. And again, I'll just do the FP3 files, select them all. Okay, the results are on the spreadsheet, and I can drop them in. So there's an awful lot of columns there, but you expect most of them to be the same. The fixed amplifier gain, this one, that's a sort of personal setting for each pod, so that does vary. But things like the high pass filter, you don't expect to vary. And if I graph that, oh no, that's not going to work. If we just read down that column, you can see they're mostly 40, but these 3 are at 80. So that's not ideal. So you can very quickly look through all the settings of all your pods, all the files, check that that they are uniform. Okay. So now we come on to something a bit more meaty, which is exporting raw data. So what I'll do is open a file set, and we'll use the Babitonga file, which you will have downloaded. So you can click on either the FP1 or the FP3, and it will open one copy of the FP1, which is in file slot 1, and 3 copies of the FP3. And you can change these to whatever suits your taste. I kind of chop and change them quite a bit. So what I'll show you first, actually, is something that probably not many people will use. But if you we'll just do show from start, show next screen. This is the first click train in this file. It actually isn't classified to a species. So this second panel, which shows species class, is gray for unclassed. And up here where it's showing clicks per second, you can see there are 2 click trains running along together, and one of them is green, which means it's low quality. So you probably would never have seen those, but so this is a weird click train. The pod actually isn't even in the water here, but they're very uniform, low amplitude. And if you wanted to look at the data in detail on this, you right click and you select put raw data into clipboard. 84 clicks are on the clipboard. Drop it into Excel, and you've got details of the 84 clicks, or 83 was it, that are in there. And you've also got this number, train ID number. So there were actually 2 trains there, and they overlapped in time. And in every minute, the first train found is called number 1, and they go up to a maximum of 255. So if this column here is the minute, they're all going to be in the same minute. And this is the number of microseconds into that minute. So I'll just graph that. And you can see that it's got a bit of a ripple down here. It kind of increases, then there's a jump, and then there's another, basically a gap and another train. If I sort it by train ID, the 2 overlapping trains are now separated out. So they both start at about the same time, and one of them stops much earlier than the other one. Yeah, there are various headings there. I won't go through all of them, but this is where the most fine-grained data is. Not many people look at this. I kind of look at it a lot for different questions, and so do people studying train structure and various other things. But for a lot of projects, you wouldn't actually be using this. Okay, so that's exporting the very fine, detailed data. There's another thing again, which you can export, which is of a very niche interest, but I'll just quickly show it to you. On the about page, you can export the source code that that actually shows you how the data is unpacked. It's like all sort of source code for programming. It's in a text format, and there's a scarily large amount of it. But it is there, and if you need it and you have any problems understanding it, let us know. Okay, so now we get on to the meaty stuff, which is the kind of thing that you'll want in nearly all projects. So we'll go back to what you normally look at, which would be high and moderate quality trains of narrowband high frequency species like porpoises and some dolphins. All the other cetaceans and boat sonars will fit the whole time range on the screen. We'll show frequency in the first one there. Show from start. So this is the Babitonga file that you've got. I'll just scale these down with F6. So when you look at this file, this line is the temperature, and these tiny lines here, I don't know if they really show up, because I'm on a 4K screen. Is that showing up on lower resolution screens? I hope it is. Anyway, what it's telling us is that for a period at the beginning of the file, the pod is basically hanging downwards, and the same at the end. And it's the temperature is kind of stable while it's in the water, and as soon as it comes out, it warms up. So normally you work with a file that's cropped, and Dan explained that in the first of these tutorials. And you can crop exactly to the ends of days. But here we've got the whole file as read from the pod. This is data from Hernan Paytach, who did his PhD on Franciscanas, and got very, very good results from that work. Okay, so Probably the first thing that you would choose to export is you go to the export page and you pick this one in section A here, detections and environment. Maybe I should mention there are various options up here that you can use. One of them, search directories. You know, we're saying keep all your files in one directory, in which case you don't need that. And I've recently discovered that occasionally this misses a subfolder, so that reinforces the wisdom of having all your files in one directory. So detections and environment, you're generally going to want this either in time units of hours, so you can see DL patterns through the day, or days, in which case you can see the trend over time within your project. Here we've only got 4 days or so of data, just so that we can do everything quickly. So I'll do the hours option here. There's this option here, which is really useful, omit negative time periods. If you had people doing sea watches and they wanted to know when the pod saw or heard the dolphins, you would select dolphins, you'd do number of clicks per minute and omit negative time periods, and it would give you a list of the minutes when the pod thought it heard dolphins, and you could hand them that and it would kind of be reasonably brief and make sense to them immediately. However, we're going to do hours, we're going to do the whole file. We could do it from a batch of files, but actually we've already got this one open. So file slot 1 was the FP1, 2, 3, and 4 were the FP3. That's 2, 3, and 4. So they're all exactly the same. Doesn't matter which you pick. We'll pick number 2 and export that. There it is. It's got the header on it. I don't really want the header because I want to just drop it straight into a spreadsheet, export from. Okay, there it is. Cut to clipboard and drop it into Excel. Okay, so this is the kind of really useful stuff. Again, I will just delete these 3 columns, which are constant all the way through, just to give us more space on the screen. Okay, so and I'll just freeze the top row. So minutes on here is we're exporting hours, but the number of minutes on isn't the one at the beginning and the one at the end are incomplete. So normally you would remove those, but don't remove them at this point, and we'll see why shortly. Then we've got the number of detection positive minutes of NBHF clicks purposes. Okay, so that is kind of paralleling the graph we saw in the pod software. This is the number of clicks, which should be exactly the same. So just to check it is the same, I'll just sum those. And it says 107,732. So if I go back to the software, just select purposes here, go to the analysis page and analyze file 2, I get 107,732. This analysis page is not really part of exporting, but it is awfully useful for getting a check on, have you got like really weird data here for some reason? This is not weird at all. You know, the frequencies where you expect it to be, the number of cycles goes from 1 up to a peak here. This sort of fits porpoises, click rates, bandwidth. Yeah. So it actually is a good idea to do a lot of these checks because this is rather complicated software. There's an awful lot of buttons you can hit and check boxes and so on, and just to make sure you're getting it right. I do quite a bit of checking. Another thing I should say there, actually, because of this problem that you've got a lot of things you can get wrong, on exporting over here, we've got save current export settings or load them. So it's not a bad idea to save your export settings and load them, because it stops you accidentally forgetting you've set a filter over here, which we will do in a moment. Yeah. So back to the spreadsheet, you've got NBHF, detection positive minutes and number of clicks, the same for dolphins, the same for sonars. N all per minute is the number of all clicks, noise, sonars, dolphins, everything. It's kind of nice to know. It doesn't generally get used in analyses. It's kind of a difficult figure because it's got both the cetaceans, which can be the main contributor, and the noise. Time lost. So CPOD users will remember that the CPOD maxed out in noisy conditions, and yeah, this in Babatonga it didn't max out at all. The FPOD is much more resistant to losing time that way because it moves its operational threshold. So that's this average operational, and that's actually kind of the best metric of noise. So it did occasionally move that up a bit. There isn't really any very good measurement of noise you can get and export from a pod that will be accepted by most users or journals or whatever, because the relation, you know, the pod's recording ultrasonic clicks. It isn't recording the whole story about the noise. So it's a very odd kind of measurement, and probably best not to try and use it as a measurement of noise. Sonar risk. These things are they're not properly validated. They're just a guide. Same with this percentage of minutes with WUTS risks. So WUTS are weak unknown train sources. They are in some occasions really troublesome. And this thing will be improved in later releases of the Kerner-F classifier without changing the results you get. These kind of warnings will be improved. Okay, so you've got your sort of basic there, but then you might say, I really want to know what the incidence of fast click trains is from porpoises. So you go to filters and files and you say, I'll have clicks per second from 100 per minute up to 2,500, which is the highest it'll allow. And porpoises don't go up there anyway. And we'll do just porpoises over here. We will export not detections and environments now, but number of clicks per hour. File 2, Just check results is empty. Yeah. Okay, there's the list. Cut to clipboard. So at this point, you can drop it in right next to the stuff you've already done, because you didn't remove the first line, even though it wasn't a complete hour. I always check the bottom line is I've got exactly the same number, because if I haven't, something really horrible has happened. So then I'm going to delete a lot of columns I'm kind of not interested in here now. Yeah, these will all be the same. And this one is now NBHF more than 100 per second. And minutes on is again going to be the same. So you can add these selective exports where detections and environment was giving you like dolphins, porpoises, sonars, and a load of other stuff. These are much more specific, and you can, you could have any band of click rates. If you've set something, the best way to clear it is click over there, clear all blue filters. The alternative, you can double click in here, but if you get into using filters, it's very easy to forget you've set one. If you have got one set on the export page, it does tell you at the top what filters you've got. Okay, so yeah, I've sort of thrown a lot of stuff at you there. So what I'll do at this point is give you a chance to try yourself opening the Babatonga file and exporting first detections and environments per hour, and then a selective one, number of clicks of, say, porpoises or dolphins, whatever you like, and putting them into the same spreadsheet. So I will stop for, what should we say, 5 minutes, and hope you have success.
Nick, would you mind answering Jessica's message in the chat? Thanks.
It's not Jessica, it's Caroline. Is that who you meant, Dan?
Me, Jessica, I asked how does the software filter the click echoes?
Okay, how does the software filter the click echoes? It finds trains, and it quite often finds the train of the primary click and another train composed of echoes. So it's got two trains, but they obviously resemble one another very tightly. It looks for that very tight resemblance. If it finds it, it says one of these is an echo of the other one, and it then labels it as such and puts it in that fourth quality category. So you've got high, moderate, low, query, echo. Doesn't always get it right, Jessica. You can get some duplication on that account, but it's generally very tiny, less than 1% of the total. Does that answer your question?
Yes, thank you.
Oh yeah, Nick. Yeah, question from Caroline, which I did try to answer, but then I found it didn't behave actually as I thought it did. Which is when you right-click on the screen to put raw data in clipboard. Originally, I thought that was all data, but it's actually it's trying to capture just the data that's visible in that window, isn't it?
Yeah, that's correct.
But it's
So
limited. It seems to be limited to 995 rows because I tried capturing the data in a 5-minute resolution period and it still came up with 9,995 rows, but not the same ones as a 1-minute period. So
yeah, so it's what you can see with all the filters that are operating. And yeah, I've forgotten about that limit, but we'll see actually you can export click details without that limit, but
okay,
not via that right click menu.
I see.
It actually comes up in the B section of the
Mm-hmm.
data export page there.
I have to say I've only ever used it for high resolution views, so I've never hit that limit before. But it was just because I tried it in a couple of low resolution settings to see what happened, and that's where I got it.
Yeah. Okay. So
All right.
if I mean, just to say to Caroline, if you're using it and you find you're not getting as many clicks as you think you should from the click details in B there, let me know, because I don't know that many people use this at all, and to some extent you are the beta testers of this software.
What
You
do
know,
you mean by B?
so on the export page, you've got actually 5 boxes. I've just reduced it now. The next version will only have 4. So the boxes are labeled A, B, C, D, and E.
Oh yeah.
Yeah. Do you actually want all the click details?
I was just wondering if it is actually everything just by one click, one right click on the screen, if I could get all the information from the whole file or just from the screen.
Yeah,
I
you
was
do
just
just get
wondering
it
about
from the
it.
screen, and as Dan says, it's even limited then to just under 10,000.
Okay.
But you can get them from the whole file. I mean, it will be a much bigger file
Mhm.
than the pod file it came from. But I've recently had requests from a few people who are wanting to apply AI and machine learning and so on to this kind of data, and they want all that stuff. So you know, which I'm kind of happy to let people have. Yeah, so if you're using it and you're kind of having problems, let us know.
Okay. Thank you.
Nick, there's another question from Amy, which is what is the difference benefit between using the skip to function at the bottom left of the software and changing the click filters manually?
Okay. The skip to is a rather neat thing. It says it's only relevant in high resolution. I can show it to you now. Have I got something open? Yep. So we'll go to high resolution, 10 milliseconds. Show next screen. So it's showing me a screen there which has got 98 clicks in it. But if I wanted to find a lot of activity somewhere, I could put that up to say 500, and then it whizzes along and finds places with a lot of clicks. And this actually is enormously useful if you want to find social activity of dolphins, and because they tend to involve and porpoises repeated fast calls, And yeah, so I put that up too high. There is no screen in which 10 millisecond resolution will give me that number. But so it's very different from, it's basically filtering, if you like, for a lot of data in a short period of time. Is that okay?
That's great, thanks. Yeah. What would be if you changed the click filters and the click and train filters to do kind of the same thing? Is there a difference to doing that?
Yeah, the click filters here, they operate on FP1 and FP3 files. There's nothing there about how many there are in a screen. So they don't do anything kind of the same as the skip function.
Okay.
Yeah.
Okay, thank you.
Yeah, so train filters, probably the commonest use is where people want to look for fast trains. Yeah, there's or filter and look at some frequency band. Yeah.
Great, thank
Okay.
you.
Well, I'm hoping you all had success with the exporting exercise, guys, because I mean I don't know quite if you were struggling, you can either put it in the chat or send us an email, and we'll try and help with any particular problems. But one thing I should mention that's really important in exporting, it's not exactly exporting, but it's like, what statistic do you want to use? So, you know, frequently you want to know basically how many animals are there around at a particular time. And detection positive minutes per day, for instance, is quite a nice measurement. But if you've got an awful lot of animals, it can only go up to 1,440 because that's the number of minutes in a day. So it's got this limit of 100%. And in some places you can get up towards that. And you can see that when you're say halfway up, half the minutes in the day have already got a porpoise. If another porpoise arrives, it may arrive on a minute that's already got a porpoise detection. So its arrival isn't even registered. So there is a fairly simple mathematical relationship there, and we've got a poster on this that we can send you if you want. But the rule of thumb is you don't want your metric to go above about 1/3 saturation, say 30% really. And if it does, you need to use a smaller unit. So if you're on detection positive minutes, you could go to number of clicks because that can go very high. My favorite, which almost nobody uses, is train duration total, because you can have 2 trains occurring at the same time from different animals, and this counts that period of time correctly twice, you know, because you had 2 animals, and it's not confused by the click rate of the animal. So number of clicks is going to reflect the kind of activity they're doing. Okay, so that's a sort of point about what choice of statistic. Okay, so we need to look at our spreadsheet, and we've got here the temperatures and angles. So let's just plot those. And you can see that the angle, which you want to be around 0, the pod's floating up, is actually high in these periods here. That's because it wasn't in the water then. That's when we saw it's hanging down. And there's a clear sort of boundary at, say, 35 or 40. And the temperature, we can see it's going up, but then it's sort of steady. So what we can do here is we can just take all those rows where the angle is above 30 and delete them and go to the far end of it. And again, knock out all the hours where the angle's above 30. That's that set there. And then if we plot these again, we've now got only the time when it's in the water. Okay. Another thing. Oh no, I'm sorry. I think I'm getting out of sequence here. Yeah, so we need to look at the other options on the export page. So detection positive 10 minutes and hours. If you've got a low density, actually these kind of work well, because the larger the unit, it actually reduces the effect of variation between sites and instruments, which we try, and particularly Dan tries to keep extremely low. Yeah, then we've got these other train ICI inflections isn't working at the moment, I don't think. Interclick intervals, yeah, that's is currently broken. You can export interclick intervals if you want to study click train structure. Obviously, you can change the periods. Output to a text file or results. Results is generally quicker unless you've got really big output, and then it writes it much faster to a large text file. Tab separators is what's used when you drop stuff into spreadsheets, but you can get CSV files, which people using R need. These are kind of site code only. This is to try and keep the data volume small. I used to use Microsoft Access a lot. They've limited the size of it now and they're not really supporting it. So you can find, if you've got a lot of data, like the Black Sea Trends project's got, getting on for 500 million clicks, and you're really pushing the limit of access. So you're trying to keep your exports small. Okay, and then we can export train details. So we'll just do a bit of that. We'll just look at, say, the other citation, other citations. Have we still got? Oh, I think sorry, I'm jumping around a bit here. It's going to ask me to open a file. Yeah, we'll open the Babatonga file. It's going to export it into this file. I'll just name it B because I've got a couple there already. So now the results page is telling us what all the headers are meaning in this this export of train details. So I copy that file, go to Excel, data from a text CSV file, paste in the name of the text file, load it. Yeah, there we have it. So it's Oh, I see here, I've actually only got, I've got the minute number, which, as I mentioned before, there is a 2-day problem difference there. The time there is microseconds into the minute for the start of the train ID, what species it is, and all these are explained in the on the results page. Yeah, so that was full train details gives you even more. So this train details you could use in R, for instance, to get DL patterns. If you exported from a batch of files, you could have their location details in another file, and you could correct for the hour of the day and so on to get DL patterns. And the Black Sea Trends project, which has 5 countries around the Black Sea. So there's a Ukrainian PhD student, Julia Vanchikova, who's in St Andrews. She's looking at that kind of thing, at the DL and seasonal patterns around the Black Sea, and getting very interesting results out of that, as to how they correlate with fisheries data and migration data. Wave details. Okay, this needs a little bit of explaining. We'll just open the Babitonga data again. And we'll just look at porpoises. So the FPOD picks some clicks and records more detail through the click, the wavelength or the period of all the cycles in the click. So there's a filter over here on the left, train filter, marked trains included. If you click that, you get to clicks with wave only. So if I just show the whole range now, it's showing me times when it's got clicks that have got this extra detail. No more clicks in file 2. So that's because I'm skipping to 256. I'll put that right down again to and over here on the left I can select waveform and spectrum and do refresh. So it's now showing me this extra detail on the first click where it's got this. So what it's actually stored is the time and amplitude of these peaks, and I've fitted sine waves to that. So that's like a very minimal, innocent looking porpoise click. And then the next one is similar, a bit louder. Yeah, and you can see below a Fourier spectrum that's been derived from this synthetic yeah, so what I'd like to show you is a stronger one. So maybe I'll put in a filter for click amplitude here above, say, 300. So that's a louder porpoise click. So absolute classic porpoise click. Yeah, and so you might be interested in this data. I mean, the FPOD, because of its very high resolution, it's sampling at 1 million samples a second and upsampling that to 4 million, is able to show frequency trends within the click. And there actually is a tendency for them to have a downward sweep, which wasn't previously, it hasn't been written up yet by anybody. People using PAMGuard did see it just faintly from the Wigner-Ville transform plot. Anyway, that's what wave details are. So you can export the details of all the clicks that have got waveforms subject to any other filters you use. And I must remember to get rid of those filters. Okay. And then click details we talked about, can be huge volumes of data. So you can sample them. You could say 1 minute in 100 and get 1% of the clicks. And you might well choose a tiny fraction just to check it's like makes sense before you go for a big export. Okay. The next one is encounter details. These encounters have when we first started using pods, kind of everybody wanted to use encounters as well as counting animals, but we've realized that actually is a really bad idea, and they're not getting used for much actually at the moment. But this was an attempt to provide data for species discrimination work, and it reads through the file, finding encounters separated by a gap of 10 minutes, and then exporting details of all the clicks in that encounter. So it finds modal frequencies and it sort of graphs its efforts to do that. Yeah, so I don't know whether this shows up very well over Zoom, but it's sort of smoothing the set of frequencies derived in each encounter to produce values for the modes, and just it's graphing it just to kind of provide some feedback to the developer that it is actually doing it right. Yeah, so I hope I can stop it. And then it exports a lot of information on this trains page. In fact, if you're interested in developing species classifiers, we're interested as well. It's a tough problem. Some really useful discriminations like common dolphin versus bottlenose dolphin have yet to be achieved using spectral methods. We're kind of hoping that by pulling together in encounters spectral information such as it is in pod data, click rate data, high resolution time domain data about individual clicks, that we will be able to produce species discriminator, but we haven't done it yet. And I'm not kind of making any promises because it is a notoriously tough problem, but it'd be really useful to crack it. And if you're interested in working on it, get in touch. And there's another button over here, bottom right, export data for third-party analysis, which this isn't working yet, but it is not a big job to get this working. This would allow you to choose sets of data that you could export and then put into machine learning, AI, whatever, and see where it goes. Almost invariably, what you're going to need is visual labeled data to provide the answer for the machine learning to work on. And while we're here, I'll just mention that in the filters, you can filter by minutes, and one of them is by annotation numbers. So you can, if you do visual data and you get sightings, you can, from the results page, you can add sightings to the files. So you you basically have a spreadsheet with a list of times and what species you saw, and the species gets given a code, and that button reads it into and writes it into the pod file, and you can then see only the minutes with Irrawaddy river dolphin or only the minutes with bottlenose dolphin. And so then you can pull out encounters or that kind of third party stuff or anything you like specific to those minutes. So it's really cool, but has hardly been used yet. Okay, where have we got to? We've done those encounter details. We've done that. Summary of displayed minutes. Oh, have I got another? I think I might have had another infernal exercise for you. Oh yeah, okay, comes a bit later. What have I got to do now? Yeah, the whoops. Have we got any files open? No. Okay, we'll open a file set. We'll open our good friend Babitonga here. Fit the whole time range on the screen. Show from start. But this time I'm going to show in panel 1 the battery levels. Oh, they're dead constant. Of course they were going to be, weren't they? Opened the wrong file here. Close all files. Open a file set. So this one is courtesy of Leah Crow in New Zealand. Fit a whole time range on screen, 6 hours. Show from the start. So this was a pleasant surprise. She sent this data. The pod ran for just over 8 months continuously because it had one stack of lithium primary cells and one of alkaline. So it used the alkalines first because it always uses the weakest stack first. So hopefully you end up throwing away dead batteries rather than half dead batteries. And then it switched to the lithiums and they went along almost flat and then dropped off over a period of a few weeks. So it's really nice for looking at the battery levels, but actually what is also very useful is if you're looking at well, we don't want to see those, yeah. Oh, I've got batteries showing. I need amplitude. So here we've got some click trains. They're colored by the train number. That may be a bit puzzling, but here you've actually got one of these echo trains, or 3 actually, that we were talking about before. Anyway, you know, people say, how do I find out the angle and the temperature when this happened? So the answer is you go to the export page and you do summary of displayed minutes. So they're on the clipboard and it's saying it's got 5 minutes there. The temperature was 13 degrees all the time. The angle varied between 2 and 1. And it did have 5 minutes. 1, 2, 3, 4. It's only got 4 minutes. Okay, that's curious. Anyway, that is I'll have to check that out. That's giving you the temperatures and angles at that time. Right. Just check my list of topics here. Landmark sequences. Okay. So landmark sequences are very curious. We really only see them from NBHF species. And I think for this one, I'll open a file. So this is thanks to Amy, who's on the call, and her team in the Northeast Pacific from OceanWise, studying porpoises. So their data has got quite a number of porpoises in it. Landmark sequences are rather special. So on the display page, it's got minimum landmark sequence quality, generally below 9. They're not worth looking at. And actually, to see what they really mean, we probably want a couple more copies of that file. So we've got amplitude on the first, we'll have clicks per second, we'll have interclick intervals, and we'll do it on 100 milliseconds, show from start, show next screen. Now, to get to a landmark sequence, you right click and you pick go to next landmark sequence. And here it is. I'm just using F5 to upscale these. So this one is the interclick interval, and it's falling in pretty much a straight line over a period of kind of 2 minutes. And this is the clicks per second, which is the reciprocal of that, and so it'll consequently be a curve, which it is. And what's happening here is the porpoise is swimming towards the pod, and it's echolocating on either the pod or part of the rig, or we've seen it here when we've had a pod hanging below a navigational buoy in fairly deep water. So the porpoise locks on to the navigational buoy, say, at an astonishingly large range for a porpoise, like 250 meters, and clicks very slowly because of the two-way travel time. And as it, so the interclicks interval is quite long, and as it moves in, it gets faster and faster. So this slope tells you the swimming speed. We've got measures of the amplitude of the click, so you can make inferences about the hearing threshold and the click amplitude from these. Swimming speed is quite a good one, and it does give a very realistic distribution of swimming speed. So the Samba project had more than 1,000 of these landmark sequences, and in terms of exporting, what you do is you go to the trains page, you do find landmark sequences, and that runs through, and it finds them and exports a whole lot of information about them, does the calculations on swimming speeds and amplitudes and so on. So it's kind of cool because it's the only time that we know the distance of an animal from the pod. When it's weak, we don't know whether it's close but facing the other way, or distant and facing towards the pod. Okay, so that's landmark sequences. So here's a thing that actually is of more general use. So we'll just, so that's the OceanWise data again. We can graph various features, and we can export the values in the graphs. So if we look at the DL number of clicks, the DL train clicks per second, and the DL average train duration, and we do graph, but we don't want to ignore all filters. Just make sure I haven't got any set up there. Okay. So this is great fun, because down here, this is the number of clicks. The animals are kind of pretty much absent in the day, but they're there at night. So that's an interesting reflection on, you know, what the difference between acoustic and visual methods. The top one, well, we'll look at the second one. The clicks per second is higher at night, but there are some high ones in the day. But when you look down here, there's very little data down there. So basically from here to here, you've got sampling error. You know, you've only got a few click trains, and really you just have to sort of draw a line through there. What it's telling us is they're clicking faster at night when they're there than in the day. So in the day, they're not just few of them, they're doing the same thing. They're doing something different. And this one I kind of really like. This is train duration. It isn't really the duration of the train the porpoise makes. Porpoise makes quite long click trains, but it's shining its sonar beam around the world, and it just flashes across the hydrophone in a fraction of a second. So the longest ones here are like 1 second. So it's really telling us about the speed of head movement. So in the day, they're moving their heads relatively slowly. They may be swimming in some direction, and at night, they're looking around all over the place. So this kind of fits the idea that they are foraging at night. So you look at that and you think, oh, I really want to export that data. Well, it's easy enough. On the display page where you chose what to export, you can click put graph and autocorrelation function values in results. So results is empty. So we'll do graph and results has got it there. And we can drop it into a spreadsheet, and we can do hang on, let's just do it like this. So that's that same DL graph you saw. And the third one here is going to be the train duration graph. So that one's like, how fast is it, or how slowly is it moving its head? And it's moving it more slowly in the day. And this, you know, you can export all the things, this rather long list of things. I think you can export all of them. If you really want one and it's not there, do tell us what you want it for and so on, and we'd think about adding it. One of the other things here is the auto correlation function. Well, we've already seen in this data that there's a strong DL pattern. We can look at that as an auto correlation function. So if we pick a bin size of 1 hour over on the left here, and these are all the same file, aren't they? They're all FP3s. Yeah. So we select this file for action, click autocorrelation function. Okay, I hope these spindly lines show up okay on your screens. What we see here is a series of peaks that pretty much line up with the vertical lines that are at 24-hour intervals. And at least over time, they're not drifting away from that. So that is confirming that there is a strong 24-hour cycle here. It's got a couple of uses actually that are really good. One is distinguishing tidal cycles, which are just a bit shorter from 24-hour DL day cycles. And the other is kind of getting a metric of how long the animals hang around an area, which is how long the correlation takes to fall below that upper line there, which is the kind of confidence interval. So it's not quite the same as an encounter because it doesn't know anything about 10-minute intervals or anything like that. But basically what it says is if you've got an animal now, this much later, you've still got a significant chance of still having an animal there or having an animal there. Might not even be the same one. If it goes negative, it's telling you at that time interval, you're actually less likely to have an animal. So it gives you an idea of how long animals hang around an area and whether the cycle is a 24-hour cycle or something less. Okay. And to get the menu, the controls back over there, you click that. Right. Okay. So I think you may actually find exporting the graph results useful because instead of kind of copying the graphic out of FPOD, you can put the numbers into a spreadsheet or R or whatever and format them much better for whatever your purpose is. So what I'll do is give you some time to struggle with that and put anything in the chat you about this or anything else. Okay. Okay, so we've got a question on the file sightings option. That's actually on the results page, bottom left, and it refers you to a Excel spreadsheet, which you will need, and it's on the Chelonia website, and it's got detailed instructions on how to do it. And when you've done it, actually, not only can you filter the minutes like that, but you can also have it show you some text on every minute as to what species had been given as an annotation. Then there's a question: what should we check about angle and batteries? Batteries you don't really have to check. If they're not adequate, the pod stops. If they are adequate, the pod has a voltage regulator so that the electronics gets exactly the same voltage. It doesn't know how the batteries are. It just gets fed a very constant voltage. But the angle, you should look at that. So you do, detections and environment, and you graph the angle like I did, and basically, if it's supposed to be upright, you want those angles to be kind of well above 90, which would be horizontal. Do we have any examples of good deployment? I mean, the Babatonga one is a good deployment. Yeah, so you can look at that. Yeah. Okay. Does that answer your question, Anne-Marie? Okay, thanks. Right. Okay, so I'm thinking we'll kind of bring this to an end. I mean, I think for most of you, the detections and environment for days is going to be the sort of mainstay of getting out the kind of data with which you can compare sites or progress over time. I will just mention one other thing though. Changes over time on the export page. No, on the analysis page. To the right of the button where it says analyze, there's another button which says show trend analysis tool. And that shows up this thing, Pyra F. So that's not quite ready to go, but we're very close. Probably within a month, we will release that. So Pyra stands for Paired Year Ratio Assessment. It's a sort of very simple, robust way of getting trends when you have a number of years of data. And we've published a paper on it, and we're just kind of building it into the FPOD app. So it will be basically quite easy to use. It's not the most sophisticated method. You could do more with kind of Bayesian analysis, feeding into GAMs and whatever else. But this is actually quite a good basic analysis, and it's sort of robust. You can easily know when it's liable to give you misleading results, which isn't always the case with other methods. So yes, watch this space. Okay, so we'll stop the recording now and end the tutorial, but please feel free to kind of email us about anything you kind of didn't get or had problems with. Okay, thanks for joining us.